The identities on the second half of this worksheet are a bit longer than the ones we looked at in the previous video. So I've done my best to go through and highlight the major changes that I take in each step in green. And that'll stay consistent throughout each of the 9 problems that we're going to look at. So again, the green highlighted piece in each line is the major change that's happened from the previous line. So let's dive right in. So as I've stated a few times, I always want to change any negative angles or any pi over 2 minus x's or pi over 2 minus thetas that I have as my first step. I want to work with only one angle when I'm simplifying these trig identities. Additionally, when I have an identity where I already know the end result, I just have to show all of the work that gets me there. I want to start by working on the side that is most complicated, because it's quite easier to simplify a mathematical expression than it is to complicate one. So in that very first step, I'm going to start by changing this secant of negative x and this sine of pi over 2 minus x. So those are the two things that I'm changing first. That's why they're highlighted in green. Secant is an even function, which means I can just drop the negative x that's on the inside. So secant of negative x is just equal to secant of positive x. Second, I've got sine of pi over 2 minus x. That's a cofunction identity. And the cofunction of sine is cosine. Into the next step, I simply changed everything to sines and cosines. So secant, cotangent, and cosecant, each of those were changed to their sine and cosine component based on the reciprocal identities. Going down a further step, I've multiplied the 1 over cosine into every term, which is why that's highlighted in green. So this 1 over cosine got multiplied into each of the 2 terms. And from there, I can get a fair amount of simplification done. I can reduce the cosines across top and bottom. I can also reduce cosine across top and bottom in the rightmost term. And then I'm left with 1 over sine squared minus 1. After that, I can change 1 over sine squared to cosecant squared, and then cosecant squared minus 1 is an identity. It's just equal to cotangent squared. And we're done. Problem 2, I'm going to decide to work on the left side. The left and the right side are about equally complicated, but the left side looks a little more complicated, so I'll start there. Now, I've got secant plus 1 in my denominator right here. So my first step is to multiply top and bottom of my fraction by the conjugate of secant plus 1. That conjugate is secant minus 1. So I'm multiplying secant minus 1 to top and bottom. Now the denominator becomes a difference of squares problem. Secant plus 1 times secant minus 1 will be secant squared minus 1 squared, which is just 1. And then that secant squared minus 1 becomes tangent squared by one of our Pythagorean identities. Notice I've left the numerator alone. I'll work on simplifying that later. In this step, I've got tangent squared in both top and bottom. So those two should reduce, leaving me with just secant minus 1 to be the only piece that survives. From there, I needed to get this thing to look like 1 minus cosine over cosine. So I'm going to do a little bit of work to make that happen. I'm going to change things to sines and cosines. Secant of x becomes 1 over x. And I'm going to change 1 to cosine x over cosine x so that I have common denominators, and I can add those fractions together, leaving me ultimately with 1 minus cosine divided by cosine. problem 3, I again have some funny angles that I'm going to want to deal with. So I have cosine of pi over 2 minus x, cosine of negative x, and tangent of negative x. Respectively, those become sine of x, positive cosine of positive x, and negative tangent of x. So tangent was odd, so that negative came out. Cosine is even, so the negative does not come out. And cosine of pi over 2 minus x is a cofunction identity. So again, those pieces in green are everything that changed. Into the next step, I've got a 1 plus cosine x in my denominator. So again, I'm going to multiply by a conjugate here. The conjugate of 1 plus cosine is 1 minus cosine, which is where this 1 minus cosine over 1 minus cosine comes from. I'm multiplying that conjugate to top and bottom. That, of course, was the major step taken in the second step of work. That purple plus sign comes from the combination of these two negatives. So I have a double negative, which becomes a positive. Now into the next step, I'm going to multiply the 1 plus cosine times 1 minus cosine, which again is a difference of squares, to come up with 1 minus cosine squared. And on the right, I'm going to change 1 over tangent to cotangent. Now down to the next step, 1 minus cosine squared is a Pythagorean identity. So 1 minus cosine squared is equal to sine squared. So I've made that change. And then also I have some simplification I can take in this step. I have sine of x over sine squared of x. So I'll get rid of one of each, leaving me with just sine x in the denominator, and the sine x in the numerator was reduced. Into our next step, I decided to split up my fraction. So I had 1 minus cosine over sine, and I'm going to split that into 1 over sine minus cosine over sine. Just splitting that fraction into two pieces, still plus cotangent x on the right. Into the next step, I'm going to take some reciprocal identities. I know that 1 over sine is equal to cosecant, cosine over sine is equal to cotangent, and then I have a negative cotangent and a positive cotangent, so those two pieces add to 0, leaving me with just cosecant of x. Right, in problem 4, I'm going to work on the left side. And again, I want to start by getting rid of any angles that are not simply x. So I have secant of pi over 2 minus x, and I have cotangent of negative x. Secant of pi over 2 minus x becomes cosecant of x, because that's a cofunction identity. And cotangent is an odd function, so that negative should come out. So cotangent of negative x is a negative cotangent of x. In the next step, I changed everything to sines and cosines using those reciprocal identities. And then into the next step, I'm going to want to use another conjugate. I have 1 minus cosine x in the numerator, so I'm going to multiply top and bottom by its conjugate, which is 1 plus cosine x. So 1 plus cosine over 1 plus cosine. Now I combined the pieces in the numerator, again using difference of squares. 1 minus cosine times 1 plus cosine is 1 minus cosine squared. And that is a Pythagorean identity. I know that 1 minus cosine squared is equal to sine squared. Now I have sines in both numerator and denominator, so I can reduce some of those. The sign in the denominator reduces with one of the signs in the numerator, leaving me with just sine x in the numerator and 1 plus cosine x in the denominator, which is the thing that we were trying to show. Okay, problem 5 has quite a bit going on. But again, I'm going to start the same way that I always do. If I have any angles that are not simply x, I'm going to change those first. So I have a cosine of negative x, I have a cotangent of pi over 2 minus x, and that's where we'll start. Cosine of negative x is just cosine x, and cotangent of pi over 2 minus x is just tangent x. Both of those pieces highlighted in green. Now I also elected to use a Pythagorean identity right away as well, because I can tell I'm going to need one. So you could have used all of this together to say that negative cosecant squared plus cotangent squared is equal to -1, which can be rearranged using a Pythagorean identity. I'm showing a couple more steps this time, but if you want to jump straight to -1, that's fine. So what I did was I took just this cosecant squared of x and changed it to 1 plus cotangent squared of x. Keeping in mind that I'm going to want those parentheses there because it's just cosecant squared that is equal to that entire expression. And I'm going to need to distribute that negative through my Pythagorean identity. Into the next step, I'm using the reciprocal of tangent x to be cotangent x in order to move that tangent x out of the denominator. So 1 over tangent x is equal to cotangent x. Now, since things had bunched up quite a bit here, where I'd be writing a lot of green, I distributed that negative in purple again. So this negative right here from our first line becomes this purple expression after distributing it through my parentheses. Next, I have a negative cotangent squared and a positive cotangent squared. Those two pieces add to 0. And we're going to change a few things over to sines and cosines. I'm going to start with just secant x and have it become 1 over cosine x. Then, into the next step, I'm distributing that 1 over cosine, which is still showing up in green. So I get sine over cosine plus cosine over cosine times that whole quantity times cotangent, and then -1. And then I'm going to use some reciprocal identities and some other simplification into the next step. Sine over cosine is tangent of x, and cosine over cosine is 1. Into the next step, I'm going to distribute this cotangent of x through my parentheses, which is where these two green highlighted cotangents come from. Distributing all the way through, tangent times cotangent on the left, and 1 times cotangent on the right. Now, tangent and cotangent are reciprocals of one another, so tangent times cotangent is just 1. So now I have 1 plus cotangent minus 1, which simplifies to just cotangent. All right, in problem 6, I do not have any angles that need changing. All of my angles are already x, but there is a bit that I'm going to need to FOIL out. So I did notice that there is a secant minus tangent squared in the numerator as well as a secant minus tangent in the denominator, but you have to be careful about trying to reduce those immediately, because in order to reduce inside of a fraction, I would need to reduce a factor of secant minus tangent in every term, and there is no secant minus tangent in this plus 1 term. So because there's some addition going on in the numerator, I am not able to reduce those terms right away. So instead, I had to FOIL out secant minus tangent squared. And that's everything that we see here in green. Secant squared minus 2 secant tangent plus tangent squared. All of that green bit is just what came from FOILing out secant minus tangent squared. And in the first step, that was all I elected to do. Now in purple, moving from the first step to the second step, I've put a box around that tangent squared plus 1 right at the end, because I can use a Pythagorean identity on those two pieces to say that tangent squared plus 1 is equal to secant squared, which is the piece that's highlighted in purple right here in the second step. Now I'm going to combine some like terms. I have a secant squared and a secant squared. Adding those together gives me 2 secant squared, which is the only step I took getting to that third line. Next, I've noticed that in my numerator, I have a factor of secant in every term. In fact, I have a factor of 2 secant in every term. So I'm going to factor that out of each of my two terms. If I factor 2 secant out of 2 secant squared, I am left only with secant. And if I factor 2 secant out of negative 2 secant tangent, I am left with only tangent. Now getting into the next step, this is where everything is being multiplied in the numerator, which means I am now able to reduce a factor of secant minus tangent from numerator and denominator. So those two terms reduce, leaving me with just 2 secant over cosecant. If you're comfortable with the identity, right here we could say that secant over cosecant is equal to tangent x. So if you're comfortable with that identity right away, you could stop here. If you're not as comfortable with that identity or would like to see more steps, then you're in luck, because I have those. So I'm going to change secant to 1 over cosine, and then I'm going to change cosecant to 1 over sine. So just changing secant and cosecant into sines and cosines. Now dividing by a fraction is the same as multiplying by a reciprocal. So 1 over cosine divided by 1 over sine is sine over cosine, and that is a reciprocal identity that we know is equal to tangent of x. All right, problem 7, I'm going to work on the right side because that's the one that's more complicated, and I'm back to having angles that are not simply x. In fact, I have 4 of them. Every single function in this trig identity has an angle that I'm going to need to deal with. So in that first piece, I have secant of negative x, which is just equal to secant x. I also have tangent of negative x, which is equal to negative tangent x. But notice here that I'm changing tangent of negative x on the tangent level, not the tangent squared level. So tangent squared is the same thing as tangent of x squared. So I've pulled this exponent outside of the parentheses so that I can just work with tangent of negative x. because that negative needs to come out on the inside of those parentheses. Moving into the denominator, I have a co-function identity on cosecant, so that's just equal to secant of x, and cosine of negative x, cosine is even, so I can simply drop that negative. So notice there is no double negative in the denominator. I still have secant x minus cosine x. Now, dealing with that numerator, I actually have a triple negative on that tangent because I'm squaring the negative that's on the inside and I have a negative that's still on the outside. So really, this negative that's here is still that blue minus sign that we had originally. So when I square negative tangent x, that negative gets squared away, but there is still the third negative that was on the outside of negative tangent squared. So my numerator should still remain secant squared minus tangent squared. And that is a Pythagorean identity. I know that secant squared minus tangent squared is equal to 1. And then into the next step, I elected to change everything to sines and cosines. Really, that just meant changing secant to 1 over cosine. Now I've got an extra denominator going on that I would like to clear. So because I have this extra 1 over cosine within my denominator already, I'm going to multiply top and bottom by cosine of x. This is where this green part came over here on the right. Multiplying that all through, cosine times 1 is cosine. Then I have 1 over cosine times cosine, which is 1, and cosine times cosine, which is cosine squared. One minus cosine squared is a Pythagorean identity. I know that that's equal to sine squared. And then, because I need to get this thing into the right form, I am going to separate my denominator into sine times sine, and then also separate that out so that I have cosine over sine times 1 over sine. That way I can change those pieces into cotangent x times cosecant x. All right, problem 8, again, has quite a bit going on. So let's try and take this one step at a time. My first step is always to change any angles that are not simply x. So sine is odd, so sine of negative x becomes negative sine of x. Secant of pi over 2 minus x is a cofunction identity that becomes cosecant of x. And cotangent is an odd function, so cotangent of negative x becomes negative cotangent of x. Now that I've simplified all of that, I notice that once again I have a denominator that probably should be multiplied by its conjugate. So I'm going to take the conjugate of cosecant minus cotangent, which is cosecant plus cotangent, and multiply that to top and bottom. I'm not going to distribute the numerator, I'm just going to use difference of squares into the denominator to say that cosecant minus cotangent times cosecant plus cotangent is cosecant squared minus cotangent squared. Also, I have moved this negative sign that used to be in the numerator to be out in front of my fraction. Now that denominator of cosecant squared minus cotangent squared is an identity. In fact, it's one of the Pythagorean identities. I know that that's just equal to 1. Now that I've gotten rid of my denominator, I'm going to change everything to sines and cosines. So cosecant x becomes 1 over sine x. Cotangent x becomes cosine x over sine x. And then I can distribute that negative sine x all the way through. Just be careful with that negative sign, because that negative sign gets multiplied to 1 over sine x, which becomes negative 1, but also negative sine multiplied into cosine over sine becomes negative cosine. But then I have 1 minus 1, which is 0, leaving me with just negative cosine of x. Problem 9. Again, anytime I have angles that are not simply x, I want to start there. So tangent of pi over 2 minus x becomes cotangent x. And cosine, which is an even function, cosine of negative x becomes just cosine of x. So there is no double negative on that negative cosine of negative x. So it should remain minus cosine x. Also, I have a Pythagorean identity that I'm going to knock out in this first stage. Cosecant squared minus cotangent squared is equal to 1. Next, I'll be changing things to sines and cosines. Cotangent becomes cosine over sine. Cosecant becomes 1 over sine. And then if I'm dividing by 1 over sine, that's the same as multiplying by sine over 1. So now it's a matter of distributing that sine over 1. So 1 times sine is sine. Cosine over sine times sine is just cosine. And then cosine minus cosine adds up to 0, so I'm left with just sine of x.